So this time I'm using two blades with my hacksaw to create a thicker cut. Now we all know that welding of aluminum and iron is always difficult. As you can see on this piece, the solder has got stuck only to the iron piece and leaving the aluminum piece as it is. And still, as you can see, it is stuck because the solder has locked the aluminum piece from all sides like screws. So let's hope that this works. Now this spot weld was weak, so I had to do this additional arc welding, but no arc welding has been done here. This spot weld is good on its own. You can see I have bent the screw a little bit and it has still not come out. The spot weld is very strong. Hi, in this video I'm going to salvage components from this 20 years old CD player. So first what I've salvaged are 3 DC motors. Next one is this huge transformer. After that are some plastic gears for the motors, some springs which might be useful in some of my future videos. Plus I've also got this laser for future experimenting, large number of screws which are very useful, some wires, and last are some electronics components like capacitors, resistors, and some small and big diodes. So now it's time to test the transformer. Turning it on, and the transformer is working. So it's a 12 volts transformer. Let's check the other pinouts. This one is 11.19. Now these two remain. Here the output is 11.84, so all of them are 12 volts. So that's a 12 volts bulb. Turning it on, you can see it's quite bright. Plus these motors can also be used as toy generators for experimenting. Beautiful. Hi, I got this product from Banggood. This is my new BLDC motor controller. You are already familiar with my old controller. Now the differences between the two are this one comes with a good case and a pre-installed heatsink. Unlike this one, I had to set it all up. Now this controller ranges from 20 to 50 volts DC and up to 12 amperes, which is rated, and 15 amperes is the peak, while this one is rated for 15 amperes but the voltage rating is only 12 to 36 volts DC. And finally comes the power capability. This one is 500 watts and this one is 600 watts. Although this controller does not comes with the reverse switch, you have to add it yourself. Now let's have a closer look at its build quality. You can see how thick the heatsink is that they have used. That's the inside view of the circuit, and that's the provision for your Hall type of motors. Now let's start with the connections. Here if you see, those are the grooves, and here we have the points, so it's going to go like this. Next comes the DC input. You see positive and negative from my variable 24 volts power supply. Now the power supply has been connected to the controller and it is going to feed in 24 volts maximum to my controller. Also for testing, I'm going to use this 24 volts 400 watts wind turbine generator as the BLDC motor here. So starting with the test, first turning on this power supply to the max, and here we have the indication. Now let's turn this one because I'm not sure if it is turned on or not. Nope, I'll have to turn it on. Yeah, it's on, and now yeah, and it has started running. So let's increase the speed. Now let's turn it off. Yeah, it's closed. Reducing it to 0, turning it on. Increasing. Let's go max. That's full. Now this motor is 24 volts, but it is designed for a very low RPM because it is a wind turbine generator, which you already know. Now moving on to this 24 volts 500 watts e-rickshaw motor. So this is a high current one. Let's test it. So let's see if this power supply is strong enough to handle this kind of load, and same goes for the controller. That's to the minimum. Starting it, it's on. Slowly and slowly, it's running. Let's increase the speed. It's actually quite nice. Torque is also really good. Wow. More. Oh, it's really nice. More. Oh. That's quite a high speed, but we don't have enough amperes coming in from the power supply. It is only 3 amperes from the power supply maximum. Let's go full. And here if you can see how the voltage has dropped from 24 volts to 22 volts, which means that it is consuming full amps from the power supply. And if I'm going to stop it or put my finger over here, the voltage is going to reduce further because it is not able to provide enough current to the motor. You see 21, 20. So torque is really nice and the controller is awesome. So here we have an amazing controller, brushless controller capable of handling load of up to 600 watts. This is a 500 watts motor. This can handle 48 volts, max of 50 volts and 600 watts. Unlike the previous one, which was this one, this was 500 watts. And also the maximum voltage of this controller was only 36 volts. And this one is 50 volts, as I already told you. Now let's connect a power supply that is big enough to handle that much current. Now I'm going to use this huge power supply from an old printer. Let's have a look at its label. It's 32 volts and 5.6 amperes. So this is the biggest one that I have with high voltage as well as high current. So I've turned on the power supply. As you can see the indication there. Turn the switch on. Okay. Increasing. More. 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 Super high speed, but we are still not at full. It's a pretty huge speed. Yeah, super high torque. Let's go more. Oh. Let's increase further. Oh, the speed is so high. Let's go more. So that's the maximum speed, a very high speed. Now, despite of all the pros of this controller, there is still one important thing missing: a switch for changing the direction of rotation of the motor. So before connecting the switch, you will have to take out the ground wires. After that, take one wire from the switch and connect it along with the rest of the 2 wires. Done. Now we have one more wire left that will be connected to F/R, which is forward and reverse, and that's it, you are done. Now for demonstrating the direction changing of the motor, I'm going to use this smaller one because it is a low RPM geared motor, so it will be easier for you to see the change in direction. So let's turn on the supply. Okay, now we have 3 switches. This is on off, this is for changing the direction, and this is for changing the speed or speed control. So let's start with this one. Slow starting. Yeah. So at present it is running in the anti-clockwise direction. Now let's reverse it, turning the speed to 0, and the reverse switch that we just connected, it's on. Now let's see if it is clockwise this time. Yeah, and we are clockwise this time. So now our BLDC motor controller is fully complete. It has reverse, it has stop switch, and it has speed regulation.